Hello students. So today we discuss about the different reactions of phenol, and the first reaction is reaction of phenol with acid chloride and acidic anhydride. So phenol is nucleophilic in nature due to the lone pairs of electron in oxygen atom, and these lone pairs of electron act as a nucleophile. When this phenol react with acid chloride, that is CH3COCl, then it produce phenolic ester or phenyl acetate, it is OCOCH3. And in acid chloride, this carbonyl part act as a electrophilic center because oxygen and chlorine withdraw electron from this carbon atom, and this carbon atom suffer from electron deficiency. That's why this lone pairs of electron easily attack to this carbon center and carbon oxygen bond will break. After that it produce benzene O, CO minus, Cl and CH3. Then this chlorine minus remove from this intermediate and this produce ester. That is the mechanism of this reaction. Similarly, when phenol react with acidic anhydride, then it also produce ester, and for acidic anhydride, the acetate group, this acetate group act as a leaving group, and similarly this lone pair attack to this carbon center and this carbon oxygen bond will break and it produce this intermediate, and here acetate group, this acetate group act as a leaving group and it is removed as acetate ion, and this produce again ester. So when phenol react with acid chloride or acidic anhydride, in both of case it produce ester. When phenol react with benzoyl chloride, that is benzoyl chloride, so similar reactions happen just like acid chloride. This lone pairs of oxygen attack to this carbonyl center, and after that chlorine minus ion remove as leaving group. So it produce again ester, and this ester known as phenyl benzoate. So this is the reactions of phenol with acid chloride and anhydride. Next one, reactions of phenol with ammonia. So the next reaction is reaction of phenol with ammonia, and this reaction actually happen in high temperature, that is 300 degrees centigrade, in presence of anhydride zinc chloride, and this zinc chloride actually act as a Lewis acid and enhance the rate of the reactions, and here involve a nucleophilic substitution reactions and produce aniline as a product. So this the reactions. So when phenol react with ammonia in presence of anhydride zinc chloride at very high temperature, then it produce aniline. Next reaction is reactions of phenol with zinc dust. And when phenol react with zinc dust in presence of acidic water, then after condense this phenol transfer into directly benzene ring with zinc oxide. So by this reaction we can prepare benzene from phenol. So this is the reaction. Next reaction is halogenation reaction of phenol. Halogenation reaction of phenol. And you know, when benzene react with halogen, then they are required Lewis acid. But phenol is more nucleophilic in nature compared to benzene. So halogenation of phenol occur in absence of a Lewis acid. So when phenol react with bromine water, then directly it transfer 2,4,6 tribromophenol. But this reaction when occur in presence of carbon disulfide solvent at 0 degree centigrade, then two products were obtained, that is orthobromophenol and parabromophenol. And you know, due to steric hindrance, here two OH and bromine group present at the adjacent position. So due to steric hindrance, this orthobromophenol produced as a minor product, but in case of parabromophenol they present less steric hindrance, so this parabromophenol act as a major product. Actually in water solvent, the phenoxide ion produce negative charge to the ortho and para position. So in water solvent, this phenoxide ion resonance, and after resonance it produce negative charge at ortho and para position. That's why this both two ortho and para position will react with bromine and produce 2,4,6 tribromophenol. But in presence of non-polar solvent, the nucleophilicity of this phenoxide ion decreases and it produces two product, that is orthobromophenol and parabromophenol. Similar type of reactions occur with chlorine. When phenol react with chlorine water, then it produce 2,4,6 trichlorophenol. Next one is nitration of phenol. So the next reaction is nitration of phenol. And actually nitration occur in presence of nitric acid. So when phenol react with nitric acid at ordinary temperature, then it produces two products, that is orthonitrophenol and paranitrophenol, that is orthonitrophenol and paranitrophenol. And again orthonitrophenol act as a minor product and paranitrophenol act as a major product. When phenol react with sodium nitrate in presence of HCl at lower temperature, that is when phenol react with NaNO2 with HCl at a very low temperature, that is 0 to 5 degrees centigrade, then it produces para-nitrosophenol as a major product, that is OH N double bond O, that is the para-nitrosophenol, and this para-nitrosophenol produce 90% as a product. And when this para-nitrosophenol again react with dilute nitric acid, and it is further oxidized to produce para-nitrophenol as a main product, and here no side product occur, which is occur in the previous reaction. So this is very important reaction. So by this reaction we can only prepare para-nitrophenol and no side product produce. When phenol react with sulfuric acid, then it produce mixture of two product. When phenol react with sulfuric acid at 100 degrees centigrade, then it produce mixture of product, that is these two mixtures of product. And when these mixtures of product again react with nitric acid in 100 degrees centigrade, then it produce 2,4,6 trinitrophenol. It produce 2,4,6 trinitrophenol. That is the reaction. And this 2,4,6 trinitrophenol also known as picric acid. This 2,4,6 trinitrophenol also known as picric acid. Next reaction is sulfonation of phenol. And you know, in presence of concentrated sulfuric acid, phenol react with this sulfuric acid to produce sulfonilic acid. But here two type of reaction occur at room temperature near about 20 degrees centigrade. When phenol react with concentrated sulfuric acid, then it produce orthophenol sulfonic acid, that is OH SO3H as a major product. And when this orthophenol sulfonic acid further heated to 100 degrees centigrade, then it transfer into paraphenol sulfonic acid, because due to steric hindrance this orthophenol sulfonic acid is very unstable, so it produce SO3H at the para position. But if you directly heated this reaction mixture, that is phenol when react with sulfuric acid or concentrated sulfuric acid in presence of 100 degrees centigrade, then it directly transfer into SO3H. But at ordinary temperature it first produce orthophenol sulfonic acid, but after heating this orthophenol sulfonic acid transfer into paraphenol sulfonic acid. But if you heat directly, then directly transfer into paraphenol sulfuric acid. Next one, Friedel-Crafts reactions of phenol. And you know, Friedel-Crafts reaction, there are two type of Friedel-Crafts reaction, that is Friedel-Crafts acylation and Friedel-Crafts alkylations. So we discussed about Friedel-Crafts alkylation. when phenol react with alkyl halide in presence of anhydride aluminum trichloride, then it perform a Fredel-Crafts reaction and transfer into ortho product or para product. For example, when phenol react with methyl chloride in presence of AlCl3, anhydride AlCl3, then it produce orthocresol and paracresol. That means this is known as orthocresol and also produce paracresol. This is known as paracresol, and again due to steric hindrance this orthocresol product unstable and this paracresol product more stable due to less steric hindrance. So these are few reactions of phenol. Next day we discuss about the other reactions of phenol, and there are some named reactions also, that is Kolbe-Schmidt reactions, Reimer-Tiemann reactions, Gattermann-Koch reactions. So next day we discuss about these named reactions where phenol performed as a reactant. Thank you.